So hello all. Today in this lecture series of computer organization and architecture, I will be discussing the types of addressing modes. So the first type is implied addressing mode. Implied addressing mode. Then we have immediate addressing mode. Immediate addressing mode. Then register mode, or you can say register direct or register mode. Register mode. And we have register indirect mode. Register indirect mode. And then we have auto increment and auto decrement mode. Auto increment mode. And auto decrement mode. After that we have direct addressing mode and indirect addressing mode. Direct addressing and indirect addressing mode. Indirect addressing mode. And relative addressing mode. Relative address mode. Then index address mode. Index address mode and base register mode. So these are some 11 addressing modes, and these addressing modes are not static. Okay, according to the CPU organization, according to the internal architecture of a CPU, we can have more or less addressing modes. Okay, so these are some basic addressing mode that all general purpose computers will have. So what is implied addressing mode? Okay, what is implied addressing mode? So implied addressing mode means that address is implied in an opcode itself. Okay, like INCA. What does INCA means? It's an instruction which is specifically used for incrementing the contents of an accumulator. Okay, so it will increment the contents of accumulator. So here A is not an address. Okay, A is not an address. A is implied to the addressing that opcode. Okay, A is implied to the opcode. So A is not an address here. So it is implied addressing mode. Okay, and after that we have immediate addressing mode. Immediate addressing mode. So in immediate addressing mode, example of instruction having immediate addressing mode like LD5 or load 5. So here 5 is constant and we are not giving any addresses here. Instead of that we will be giving some constant value. Okay, so an immediate value is given, and immediate value is given in place of operand. In place of address field of instruction, we will not be giving any addresses. Instead of that we will be giving some constants. So it is immediate addressing mode, and immediate opcode will be given. Okay, so after that we have register mode. Okay, let's discuss this register mode. Okay, I hope you will you have understand that what is implied addressing mode and what is immediate addressing mode. Now come on to the register mode. In the register mode, let's say we have an instruction. This is the instruction format. This field is reserved for addressing mode. This field is reserved for opcode. Opcode means the type of operation which you will be going to perform on the operands. Okay, okay, this is operand field. This is operand field. This is operand field. And in this operand field we will be giving some addresses. Okay, let's suppose in this opcode field, if we give the direct value, let's say 5, and in opcode we have given a set of bit which denotes for addition. Okay, so what it will do, it will add 5. It will add 5. So but in case of register mode, in this operand field we will not be giving a direct value. Like in case of this immediate addressing, we will be giving the immediate value, an immediate operand. Okay, so in register mode we will not be giving immediate operand. Instead of that we will be giving the address of a register. Okay, let's suppose we have 8 registers in our CPU. We have 8 registers from R1 to let's say from R0 to R7 we have 8 registers. Okay, so in order to denote these 8 registers, 3 bits are required. 3 bits are required, like 000 for R0 register, 001 for R1 register, 010 for R2 register, 011 for R3 register R3, and 100 for register R4, 101 for register R5, 110 for register R6, and 111 for register R7. If we have 8 registers in our organization, so we need 3 bits. Okay, so any of the addresses, any of the 3 bits we can place here. If we, let's say if we place 010 in this address field, so this means that we have to take our operand from R2 register. This denotes R2 register. This is the address of R2 register. So we have to take our operand from R2 register. What are the whatever the contents present in R2 register? What are the contents present in R2 register? Let's say 5 is present in R2 register. Okay, R2 is holding 5. So we have given the address of R2 register, that is 010. So the contents of R2 register will be copied, okay, and our specified operation will be performed according to the opcode, given opcode, okay. If we have given the opcode addition, it will add 5. If we have given subtraction, it will subtract 5, okay. And in this register indirect mode, in register indirect mode, in this register indirect mode, the concept is similar. The concept is similar to the register mode, but in the register mode we have 5, okay. We have 5, the operand, 5 as an operand, okay. But in case of register indirect mode, we will not be treating 5 as an opcode. In place of treating 5 as an opcode in register indirect mode, we will be treating it is an address of a memory, okay. Here is some memory, here is some memory, and we have addresses like 0, 1, 2, 3, 4, 5, okay. So what does register indirect mode means? This is our instruction register, and we have given the address of R2 register here. So what it will do, it will go to the register R2 and 5 is stored. It will not take 5 as an operand, but it will go to the 5th location of the memory. By seeing 5, it will go to the 5th location in the memory, and whatever the content stored in the 5th location will be taken as an operand, okay. Suppose 8 is stored here, okay. So what we are doing in register mode, suppose the address of R2 register 010 is given in the operand field, in the address field of an instruction register. So we will be going to the register R2. By seeing this, we will be going to the register R2, and in register mode we take the contents of register R2 as an operand. But in case of register indirect mode, we will not be taking the contents of R2 register as our operand. Instead of that, we will be going to the location, whatever the contents of R2 register, we will be taking as an address of a memory, okay, and we will be going to that address and fetching our operand, and we will be and then we will be performing our operation according to the opcode present, okay. And then we have auto increment mode, auto increment or auto decrement mode, okay. In auto increment or auto decrement mode, the address of memory stored in the register is incremented or decremented by 1. The address of memory stored in a register is incremented or decremented by 1, okay. And this incrementation and decrementation is not the functionality of a CPU, okay. It is not the functionality of a CPU. So if we are using auto increment mode, so what will happen in auto increment mode? Suppose we have given this address, okay, and this is the address of register R2, and R2 holds the address of opcode of operand present in our memory, okay. It holds the location of a memory where our operand is present. So in auto increment mode or in auto decrement mode, the address present in our registers will be incremented or decremented by 1. If we are using auto increment mode or if we are using auto decrement mode, then whatever the contents, whatever the address present in our registers will be incremented by 1, or decremented by 1. Okay. Suppose if we want to access what is present in the location 6, what is present at 6th location of the memory. Okay. So we will be accessing, if we have given 5, so we will be accessing the memory location 5. Okay. In the register, if 5 is stored, we will be accessing the memory location 5. Okay. And what if we want the contents of memory location 6 or memory location 4, then we will be using auto increment or auto decrement mode in order to move up, downward or upward in a memory. So this incrementation and decrementation, it's not the functionality of a CPU, and it can be done by register, as we all know that registers are made up of flip flops, and these flip flops are connected in such a way that it can also act as counters. Okay. So registers have one property that we can increment or decrement the contents of a register present. Suppose this is some register R and it is of 8 bit register. Its storage capacity is 8 bit. So in this 8 flip flops are there. Okay. So each flip flop will store 1 bit information. We know that a flip flop is nothing but it's a 1 bit memory latch. Okay, what is latch? It is a 1 bit memory storage, you can say. So it can store up to a 1 bit memory. So in a 8 bit register, 8 flip flops are connected side by side. 8 flip flops are there, and if we want to increment, so we will be connecting flip flop in such a way that it will act as counters. So if we give some clock, if we trigger it with some clock, then this will be acting as a counter. If we have stored 5, what is the binary code? Binary code for 5, 101. Okay, 101 is stored in this. So if you want to increment it by 1, okay, so we will be giving one clock pulse and it will be incremented by 1. So what it will become? It will becoming 110. This means 6. It will be incremented by 1. So incrementation and decrementation, it's not the functionality of a CPU. Okay, we can increment or decrement the contents of a register by applying a clock pulse, a clock signal. We can increment it by 1 because registers are made up of flip flops, and flip flops are connected in such a way that it can act as counters, binary counters. Okay, now we have seen that what are auto increment and auto decrement mode. So in auto increment and auto decrement mode, we can increment the contents of a register by 1, or we can decrement the contents of a register by 1. Okay, so let's say that 5 is stored in the register R2, and in the operand field we have given the address of register R2. So it will go to the register R2 and it sees 5, so it will be reaching to the 5th memory location, and we can use this auto increment or auto decrement addressing mode in order to access the previous instruction which is stored above 5 and what is stored below 5. Okay, and now we will be discussing the direct addressing mode. What is direct addressing mode? So in direct addressing mode, in direct addressing mode, suppose this is our instruction format. This field denotes the addressing mode, this field denotes opcode, and this field denotes operands. Okay, this is the address field of our instruction. So, and this is a memory. So in a memory we have addresses from 0 to 1000, let's say 1000. Okay, and we want, and our operand is stored at memory location 100. Okay, so what we will do, we will be giving in the address field as 100. Okay, and at 100 location in our memory 5 is stored. So we have given the address of a memory where our operand is stored. So it is called direct addressing. We are giving a direct address of our operand in the address field of our instruction. Okay, so this is called direct addressing. This is our instruction format and this is our addressing field of our instruction. This is our addressing field of our instruction, and in this addressing field of our instruction we will be giving the direct address where our operand is stored. So this is called direct addressing. And let's come on to indirect addressing mode. Okay, so indirect addressing mode, if we are using indirect addressing mode, here let's say it's a memory location 5. Okay, 5th memory location. So in indirect addressing mode, so this address which we are giving in the addressing field of our instruction format, this address will not be treated as a direct address of our operand. Instead of that, it will be treated as a address of our operand. Okay, so if we are using indirect addressing mode, whatever the contents present in addressing field or in the opcode field of our instruction format, so it will go to the memory location 100. And it will not treat 5 as our operand. Instead of that, it will treat 5 as a memory location where our operand is present. Okay, where our operand is present. Same concept is with the pointers. Okay, using this addressing mode we can implement pointer in our program. We can implement pointer by using this type of addressing mode. Okay, suppose we have written a program in which we have pointers and all, asterisk p and pointers and all. So using this type of addressing mode in this instruction where we have implement pointers. So in this instruction we will be using indirect addressing mode or register indirect addressing mode. So what is the difference between indirect addressing mode and register indirect addressing mode? The difference is very clear that in register indirect addressing mode, in the operand field or in the addressing field, we will not be having the address of memory. We will be having the address of register, which will contain the address of our operand. Sorry. And in indirect addressing mode, we'll be having the address of our operand. Okay, I hope this type of addressing mode is clear to you. So let's move on to the next type of addressing mode, that is relative addressing mode. So what is relative addressing mode? So let me tell you that relative addressing mode will help in program relocation. So in relative addressing mode, the relative address is given. Direct address is not given. So a relative address is given. From that relative address, we will be computing our effective address. Okay, we will be computing our effective address. Suppose in relative addressing mode, we are discussing relative addressing mode. And we have memory, and here we have instruction branch. Okay, what is branch instruction? In later videos I will be explaining what is branch instruction and how it works and how it hinders the sequential execution and all. So it is a branch instruction, and in branch instruction we have given 321. Okay, 321, and it is at location 300. This instruction is at location 300. So how this will take place, how this branch instruction will be treated as, it will branch to location 321. Okay, it will branch to the location 321. If we are using, it will jump to the location 321. After executing this instruction, it will skip all the instructions which are coming in the middle, and it will just jump to the location 321, and it will start executing the instructions which are present at location 321. Whatever the instruction present at 321, it will branch to that. So suppose what happens if our program is relocated. What does it mean? That if our program is relocated, let's say our program is relocated to some other location, memory location, then what will happen? Instead of location 300, it will be relocated to location 600, and branch, we have given branch to 321. So according to the program that we have written, that to jump, suppose our program is starting from this location 300 and it will ending up in 321. Okay, this is our program is written from memory location 300 to memory location 321. And what if this program is relocated to the memory location 600 from 600 to 621. Okay, so if we have written some static, if we have given some static value, if we have given some direct value to the branch, so according to the program, it has to branch to the location 621, it has to branch to the location 621. Instead of that, it will be branching to some other location, that is 321. Okay, so how to resolve this? We can resolve this by using relative addressing mode. We will not be giving the effective address or direct that address we have to branch. We, in place of that, we will be giving some relative address which can be computed. Okay, so if our instruction is executing, and if our CPU is executing an instruction which is present at location 300, then what is the memory location present at program counter? So as we all know that program counter holds the address of next instruction that is going to be executed. So what will be the content of program counter when our CPU is executing this instruction? It is 301. Okay, it will be holding the address of next instruction 301, which is just going to be executed. Okay, so if in place of that branch 321, if we give branch 20, if we give branch 20, and after using relative addressing mode, if we give branch 2020, branch to 20, so what does it mean when we are using relative addressing mode? So it will reach to that memory location. Suppose we have this instruction. Our instruction format is like this, where we have field for addressing mode, and field for opcode. After that, we will be having a field for operand or a addressing field. This is our instruction format. This is our instruction format. Okay, so what we will be having in this addressing field, we will be having 320 in this. Okay, so once our CPU sees the address 320, in order to fetch the opcode, in order to fetch our operand, it will go to the memory location, it is 300. Okay, 300, it will go to the memory location 300. Then what it sees, that it is saying that branch 20. Okay, so once our CPU is executing the contents present at location 300, our program counter will be having the address of next instruction or the next upcoming that instruction in that our memory. So branch 20 means we will be adding, in order to compute the effective address, we will be adding the contents of program counter with address that is present with the branch. Okay, so what we will get, effective address equal to the contents of program counter, that is 301 plus the address 20. So our effective address will be 321. So it will branch to 321. Okay, So if our program is relocated to the location 600, here is our program from 600 to 621. So when our CPU is executing this, when our CPU is at this, and the program counter will be storing 601. Okay. So how our effective address will be calculated? So our effective address will be program counter plus address, whatever address is present in this. So our program counter is 601 plus address 20. So our effective address will be 621. So it will be branching to location 621. If we are using addressing mode, then this problem of program relocation will be resolved. So next move on to indexed addressing mode. Indexed addressing mode. Indexed addressing mode. So in this type of addressing mode is used, we have lots of registers. We have such type of CPU organization in which we have lots of registers, and in this addressing mode one register stores only the index. And suppose we have to access an array. Okay, by using this type of addressing mode we can implement array. Okay, so we have to access an array that has base address 300. Then we only give the base address in the instruction, and rest is handled by index register in index addressing mode. Okay, suppose we have given the base address as 300, and we have one register which stores the index. This is at 0 index, this is at 1, having 2, 3 and 4. So what we have to give? We have to give only the base address 300, and rest is handled by the index addressing mode. Okay, so here how we will be computing the effective address? We will be computing the effective address equal to base plus index. Base plus index. Suppose we have given the base address 300 and we want to access what are the contents present at location 3 of having what are the contents present at location 303. What are the contents present at location 303? Having the base address 300, we'll just have to give the base address 300, and after that our index, suppose if we want to reach this location, so we will be adding in base. We have given the base address as 300, and we will be giving the index of that 3. So our effective address will be 303 in this, and and the last type is base register mode. Base register mode. Base register mode. So in base register mode, the base address of a process is stored in a register and it's changed during the program relocation accordingly. And in the instruction, if we only give offset, so effective address is calculated on the basis of offset. So in base register mode, the base address of a process is stored in a register and it's changed during the program relocation during the program relocation accordingly. And in the instruction, we only give offset. So effective address is calculated on the basis of offset. So effective address is calculated on the basis of offset. In case the program relocate, the base address will be changed accordingly. Okay. So in the base register mode, what we have, we will be storing the base, okay, the base address of a process. Suppose in a memory, in a memory we have our program stored from location 100 from location 100 to location, let's say from location 100 to location 150. From here to here our program is stored in a memory from location 100 to location 150. So what we have to do, we have to store our address, we have to store our base address only. We have to store our base address only in the base register. This is the base register, and we have to store only the base address. What is the base address of our program is 100. We have to only store 100. Okay. and in instruction we only give the offset. Okay, we only give the offset. If we want to reach some location between 100 to 150, we will be giving the offset. Suppose if we want to reach the location 110, if we want to reach a location 110, so what we will be giving, we will be giving the offset. Okay, we will be giving this branch to, sorry, we will be giving here branch to 10. Okay, so what is 10? 10 is an offset which is given, and our base is stored in our base register, and to that base register offset is added. Effective address is calculated as the contents of base register plus offset. What are the contents of what is the content of base register is 100, and what is the offset? 10. 10 is our offset, so effective address is 110. Okay, and in case the program relocate, what if the program is relocated? To location 3, let's say 200. So accordingly our base, the contents of a base register will change to 200. Okay, if our program relocates, then the contents of a base register will be changed. So someone must say that this base register mode is kind of similar with relative addressing mode. We have discussed earlier. So in the relative addressing mode, in order to compute the effective address, we will be adding the address which is present in our instruction. Say we have seen here in the relative addressing mode, we will be adding the content, the address present with our instruction. We will be adding it to the with the program counter. There is no concept of base register and all. Okay, so if in a program we want to move from jump from one part of our program to the other part of our program in a single program, if we want to jump, then we will be using the base register mode. Okay, we will be storing the base where our program starts, and we will be giving some offset in order to compute the effective address, or in order to jump from one location of our program to the other location of our program. Okay, and what is different in relative addressing mode, if we want to jump anywhere in a memory location, if we want to jump anywhere in our memory location, okay, so then we will be using the relative addressing mode. So how the effective address of relative addressing mode is computed? The program counter, okay, here the program counter is working as a base register. Although program counter is also a register which will hold the address of next instruction, and in that we will be adding the address which is present in a instruction where we want to jump. Okay, so I hope these all 11 types of addressing modes are clear to you. So we will be meeting in the next lecture. So in the next lecture we will be discussing what are the advantages of addressing mode. Okay, so thank you.